Welcome back, class 11th. In the last lecture, in the previous lecture, we have discussed about the displacement time graph, velocity time graph and the acceleration time graph. And we have seen all the type of solutions like on calculating the slope, what you will obtain, on calculating the area of the graph, what you will calculate. As I said, in the next lecture, we will discuss about the equations of motion. So, what is called equation of motion? The relation between the displacement, acceleration, initial velocity, final velocity, time. This relation, if any equation possesses these factors, then the relation is called the equations of motion. Up to class 9, you might have seen the three equations. First, the v is equal to u plus at. Second, s is equal to ut plus half at square. And the third, v square is equal to u square plus 2as. Here we are going to see a new equation that is called the distance traveled in the nth or tth second. What is that? To understand the fourth equation, because you have seen all the three equations, what about the fourth equation? The fourth equation says the distance traveled in the some particular time only, in a particular second. Suppose I am giving you a time, suppose in the 10 second, any object is covering a displacement of 100 meter. In 10 second, the distance, or you can say displacement traveled in 10 second is 100 meter. So if I am asking what is the average velocity, straight you will say 100 by 10 means 10 meter per second. But if I am asking, this is the duration of 10 seconds. So if the object is moving with uniform velocity, then you can say in every second the distance traveled is 10 meter. That is why in 10 seconds 100 meter. Suppose the object is not moving with uniform velocity. Suppose you are moving in a bike, in a car, or on a bike. So it is not possible that the bike or a car will move on the road with a constant velocity. Sometimes it accelerates, sometimes it's retard, sometimes it stops at some red signal. So it counts all the time from the origin point to the destination point. Now the main topic is, suppose the object, I'm going to my last example. In 10 seconds, the person is covering the total displacement 100 meter. In 1 second, the average velocity is 10 meter per second. But if I'm asking you, what distance was covered in the 5th second only in the 5th second, if the person is not moving with uniform velocity, then at that time, in a particular time, what distance was covered by the person? That because of that equation. Suppose in the 5th second, what is the distance covered? So that is called the fourth equation. That is s is equal to u plus half a in bracket 2t minus 1. So we are going to prove all these four equations. So starting again, that what is equations of motion? The relation among the velocity, displacement, time, acceleration, means all these factors. That is called the equations of motion. But if an object is revolving about any point, means if the object is performing the uniform circular motion, then so that definition has to modify. That will be a different case. So that's why if object is moving about any point, so we have to modify our definition. What you will say, if an object is moving in straight line with some acceleration, at that time the relation among all the factors is known as equations of motion. So we are going to prove, we are going to obtain, we are going to establish the relation between them, means all the equations, all the four equations. So there are two types, means two methods to prove the equations of motion. One is called graphical method, second is called the calculus method. After the name, means in the next lecture we will discuss about it, the calculus method. But here we are going to discuss about the graphical method. It means we have to draw first a graph. So let's see about the graph. Which type is that? Simply, you have seen the velocity time graph. In the velocity time graph, if you are calculating the area, you are calculating what? Displacement. And if you are calculating the slope, you are calculating what? The acceleration. Same way, we are going to use that graph. On the y-axis, we are going to use velocity. On the x-axis, we are going to use the time. But in all the graph, if you remember, in the displacement time, velocity time, acceleration time, I had taken the initial y-axis and x-axis 0, means the graph was originating from the origin. And now suppose if I am proving the equation of motion, that is v is equal to u plus at, and the graph is starting from the origin. So what is initial velocity? 0. So equation will be what? V is equal to at only. And what we have to show? We have to prove v is equal to u plus at. What is u? Initial velocity. So we have to take some initial velocity. So shift that graph, means take, suppose the initial velocity of the object was u. After time t, the final velocity becomes v in this time t. So this graph we are going to use to prove all the equations. Let's see in the sheets. So let's start the equations of motion, that is called relation among the velocity, either initial or final, displacement, time and acceleration. For that I said we will use a graph, velocity on the y-axis and the time on the x-axis. Let's draw. So here the velocity time graph or VT graph, velocity on the y-axis in meter per second and the time on the x-axis. So if we are starting from the origin, so initial velocity will be 0 and we will get only the equation except the initial velocity, means without the factor of initial velocity. So I am considering that as this one is the axis for the velocity, so I am considering that the object is starting with some initial velocity. Suppose this is initial velocity is u, and traveling, see, with the initial velocity u, the object is performing the accelerated motion, means the velocity is increasing. You can see here the velocity is increasing with time. So if the velocity is increasing, means the motion of the object is accelerated motion. Suppose in reaching up to this point, the object takes time t and attains the velocity, a new velocity, initial was u, the new velocity v in this duration of time. So we are going to perform the first equation of motion. So we are going to obtain this equation of motion, that is v is equal to u plus at. We have seen all this. Again, you want to understand, just listen. The object is starting with some initial velocity and has accelerated motion, means increasing its velocity. After time t, it attains the new velocity, suppose v. So let's name it, this point as origin O, this point as A, this point as B, and this point, we are intersecting the point C, this point as D point. And we have to obtain, we have to prove this equation. For that, let's calculate the slope of this graph. So slope of this graph AB is what? Change on y-axis upon change on x-axis. And the slope of the graph in VT graph, if you remember, the slope of VT graph will give you what? See here, the slope of VT graph will give you acceleration. So here the slope of graph will be what? Change on y upon change on x. So this is the slope of the graph is what? The acceleration. So I am writing here direct acceleration. Change on y-axis. So initially the value of the y-axis is u. Finally the value of y-axis is v. So change is v minus u, final minus initial. So you can see here v minus u is the change on y-axis, final minus initial, because this object is doing accelerated motion. Same way, change on x-axis, final point is b. What is the value of means on the x-axis is t divided by t minus initial value is 0. So this is here. On solving, a is equal to v minus u upon t, or you can say v minus u is equal to a t, or you can say v is equal to u plus at. So we have proved our first equation of motion. Now see the second equation of motion, that is s is equal to ut plus half it square. So if you remember the displacement in this one, if you remember that from the velocity time graph, if we are calculating the area covered by this graph, will give you what? The displacement of the graph, means of the object from A to B. We are using this graph, so let's calculate the area, means let's calculate the displacement traveled by object from A to B point in the time of 0 to t. So we are going to calculate what? The area covered by AB. So the area of graph AB is what? So this is equal to area of trapezium ABCD OA. ABCDOA. So if we are considering the area of trapezium, so you can calculate, but you can also split this into two parts. Here you can see the two figure, one is triangle, one is rectangle, or simply you can see a trapezium. So if you are able to calculate using the formula of trapezium, you are welcome, you can. But if you are unable to do that, so you can split into the triangle and the rectangle. So on splitting, the area of triangle plus area of rectangle. So if you want to use the area of trapezium, you can also use the same. That equation says the half sum of perpendicular sides, that is DBD plus OA multiplied by the perpendicular distance, means OD. You can also use this one, or you can split in this form. If you are splitting in this form, then area of rectangle, length into breadth, length means OD, breadth means DC, plus area of this one is triangle, by mistake I have written. So plus area of triangle, that is half into base means AC, multiplied by the height BC. Using that, what is OD? O to D, the time. DC, what is D to C? Is same, the value on the y-axis. DC, that is 0 to U, means the value of U. If you are doing U minus 0, still you will get the U, plus half into AC. You can see AC is what? O to D. So what is there? T into BC. What is B to C? B to C means from here to here. What is the value at B? That is V. What is the value of C? That is U. So changing that means up to BC. So that is V minus U. So using that, you can see here UT we have obtained half into T is here, but instead of V minus U, see here, instead of V minus U, you can use AT. So let's put it here, AT. We can see, we can write here from V minus U is equal to AT. So we can put here. So what we have obtained, UT plus half A still, and T becomes square. This was what? Area of graph, area of VT graph gives you what? Displacement. This is displacement. So S is equal to UT plus half AT square. We have obtained the second equation of motion. Now for the third equation of motion. So we have seen in this equation the area of graph gives you what? Displacement, and you can use the area of trapezium. Now we are going to use that. So copied here, area of graph AB or area of trapezium ABCDOA, and the equation says, so here I have copied again, half BD plus OA into OD, that is sum of parallel sides into perpendicular distance between the parallel sides. Now let's fill the value. So BD is what here? See, B to D, the complete V. So half complete V plus OA, O to A, only U, initial value, into multiplied by OD. What is OD? See here, O to D, the time. So here it is time. This T from this equation, what is T? I'm writing here half V plus U. Instead of T, see, instead of T, what you can use? v minus u is equal to at, or t is equal to v minus u upon a. So this t is equal to v minus u upon a I am going to use here. Instead of t we can use v minus u upon a. So what you will see, this v plus u, this v minus u. Let's multiply half. So it will become a plus b, a minus b. So a square minus b square, like that, upon a. And this is what? Area of graph, which is s. So let's multiply the denominator of this side to the numerator of their side. So 2 into a into s going to there, and remaining v square minus u square, or v square is equal to u square plus 2as. So we have obtained the third equation of motion. This was there. The easy method means the another way is that you can write here, since we know that v is equal to u plus at, on squaring on both sides, what you will get, v square is equal to u plus at whole square, or u square plus a square t square plus 2uat. Then after u square plus a square t square plus 2uat. From this equation, means from this part, we are going to take something common, which is that u square plus 2a. So here no 2, means there is no factor of 2, so we have to put half, and a is there, so a will be remaining only, and t square here. If you will multiply, you will get the same, plus 2 is here, so nothing to do, a is here, nothing to do, remaining u plus ut only. So if you remember, ut plus half at square, we have just proved that ut plus half at square is what? S. So let's put there u square plus 2 into a. This one is what? S. And this is what? See here, v square. So this is the another way to obtain this relation. Here we are starting the fourth equation of motion, that is the displacement in the particular time or tth second. To understand this point, suppose any car is moving on any road. After some time, suppose any time t second, whatever you can say, is moving up to here. So it takes some time, suppose 10 seconds. So I'm asking the distance traveled in the 6th second. What is the distance traveled in the 6th second? For that, you can calculate using this equation, that you will put the time 6 and you will be able to calculate the displacement. But that will give you the displacement by this object up to 6th second, means suppose here the 6th second. So the total distance up to here, I'm not asking that. I'm asking the distance from 5th second to the 6th second. During this time, what is the displacement of the object? For that, what you can say, you can calculate the distance traveled in the 6th second and the distance traveled in the 5th second. Then what you will do, the distance traveled in the 6th minus distance traveled in the 5th second. So I think you can calculate the distance traveled in any particular time. Okay. So the same we are going to do. See this graph. Suppose at this point, suppose the time t here, the distance traveled we can calculate by what? By using that s is equal to ut plus half at square. And just 1 second before, what will be the time? Just 1 second before, that will be t minus 1 second. So t means distance traveled in t and distance traveled in t minus 1. We can calculate. Let's do. So the distance traveled in t second, not the tth second. It is just like the distance traveled in 6 second, like that, not the 6th one. 6 second and 6th second is very different. So distance traveled in t second. We have the equation is this, s is equal to ut plus half at square, and the distance traveled in the t minus 1 second, just 1 second before this one, means at every place of the time we have to put t minus 1. Let's fill that. So to make it different, I'm naming it this at distance traveled in t second, and here distance traveled in t minus 1 second. So u t minus 1 t here plus half a t minus 1 whole square. Let's open it. So after opening, u into t minus u half a as it is, and t minus 1 whole square means t square plus 1 square, that is 1, minus 2ab, that is 2t. This is actually t, don't be confused. So now after opening this, see here, ut as it is minus u as it is, half a is going to multiply inside, half a t square plus half a still minus this is going to multiply with 2t, so 2 will be cancelled, a t only. So see here, this is distance traveled in t second and this one is in time t minus 1. So it is very clear that this is a smaller value, this is greater the value. So st minus st minus 1, like s6 minus s5. So st minus st minus 1, where st is equal to ut plus half a t square. Now the term for the minus st minus 1, that you can see ut minus u plus half a t square plus half a minus at as it is. Now let's open the equation. So see here, after opening, all the positive sign becomes negative and all the negative becomes positive. And now you can also see that ut is positive here, ut is negative here, will be cancelled. Half a t square positive and half a t square negative cancelled. Now let's see what is remaining. Now see, u minus half a plus at, this is the u, this is minus half a, and this is at, remaining this one. So see, as it is u taking half a common, so what will be here? Nothing, so only 1, but negative is this is positive, so here it will be negative, and this is positive same, so it will be plus, a is out, t is still here, but what about 2, means this is half, so we have to make it 2t, then it will be balanced. So you can check it by multiplying inside. So what is here right now? So u plus half a, and doing that as in the equation in the starting, I haven't written that equation, so multiplying that 2t minus 1. So what we have obtained, that s in a particular time, so s tth second, so that is u plus half a 2t minus 1. This is the fourth equation of motion. Now see the question 12. A body travels in a distance of 20 meter in the 7th second, 24 meter in the 9th second. These are the particular times. How much distance shall it travel in the 15th second? This is the particular time. So we have to calculate with that equation, but for that we need u, initial velocity, and the acceleration, and the time is already given. So acceleration and the initial velocity, for that let's see what we can do. As per the question says, in the 7th second the distance is 20 meter using this. So stth 20 meter, u we don't know, half a as it is we don't know, and 2t minus 1, so 2 into 7 minus 1. So 20 is equal to u plus half a, 2 7 14 minus 1 13, or 20 is equal to u plus 13a by 2. This is equation 1. Again from the question, in the 9th second 24 meter, let's fill that using the same equation. stth is equal to u plus half a, nth 2 into nth time minus 1. So 9 to the 18 minus 1 is 17, rest is same. So 24 is equal to u plus 17a by 2. This is equation 2. Now let's subtract equation 1 from equation 2, means equation 2 minus equation 1. Let's see, equation 2 minus equation 1. After solving, u will be cancelled. So after this we are getting what? Acceleration is 2 meter per second square. Now use this value to put this in equation 1 or 2, you will get the value of u. So I am using that in equation 1, that is 20 is equal to u plus 13a by 2, a value is 2. That means 20 is equal to u plus 13 into 2 by 2. This implies 20 is equal to u plus 13, or u is equal to 7 meter per second. So we have the value of u, we have the value of a, we have to calculate the distance traveled in the 15th second. That will be this s15, that is u plus half a 2t minus 1. Let's fill the value. We have to calculate the distance traveled in 15 seconds. So value of u is 7 meter per second plus half, value of a is 2, so this is 2, 2 multiplied by 15 seconds, so 15 minus 1. So 7 plus, this is cancelled, so 1. 15 to 30 minus 1, and 30 minus 1 is 29. 29 plus 7, so this comes 36. So the distance traveled in the particular time, that is 15th second, is 36 meter. Here we have seen all the equations we have obtained and some numericals too. So in the next lecture we will discuss about the same equation, the proving of the same equation, but with the calculus method. So till then, be safe, take care, and thank you.